Usually when you picture computing infrastructure, you imagine these massive windowless warehouses humming with air conditioning.
Oh, absolutely. Usually hidden out in some remote desert
They're
somewhere.
right, just heavily tethered to the ground. But today, the most aggressive plays in the tech industry are looking to sever that tether completely. They're pushing neural networks into the freezing vacuum of orbit and simultaneously strapping them directly onto the necks of livestock roaming the fields of New Zealand.
It is a massive shift. We are essentially looking at the death of the traditional data center.
Welcome to episode 454 of AI Brief with your hosts Amin and Leah.
Our mission for this deep dive is to really unpack the developments that are fundamentally redefining where computation physically happens.
Yeah.
We're looking at Elon Musk's massive $25 billion Terafab space chip project.
And how a startup is nearing a $2 billion valuation just by applying artificial intelligence to dairy cows.
Following that, we have a comprehensive roundup of everything else moving the industry today. And we'll close out with the top trending tools you can deploy right now to cut the busy work out of your own routine.
Let's get right into this $25 billion hardware ambition. So Elon Musk just unveiled Terafab. It's this massive joint facility down in Austin, Texas, that pulls together the resources of Tesla, SpaceX, and xAI.
The stated goal here is almost hard to wrap your head around. They are aiming to produce 1 terawatt of AI compute per year.
Wait, let me stop you there before we even get into the chips themselves. A terawatt.
I know, it's roughly 50 times what the entire world outputs today.
How do you even physically power something like that on the ground? I mean, are we talking about building dedicated nuclear reactors just to keep the lights on for manufacturing?
Well, the sheer physics of that power requirement
Yeah.
is exactly why the structural approach of this facility is completely unprecedented. They're not just building a traditional factory.
Right.
The Austin facility is designed to handle logic, memory, packaging, and testing all under a single roof. If you think about the current semiconductor supply chain, an advanced chip crosses multiple international borders before it ever reaches a server rack.
Yeah, the architectural design, the silicon fabrication, the delicate packaging, these are handled by entirely different companies on entirely different continents.
Exactly. So by consolidating that entire life cycle into a single vertically integrated pipeline, you remove the massive logistical bottlenecks that currently limit global compute output.
So they are bringing every single step in-house to force that terawatt goal into reality. But they're actually planning to produce 2 distinct types of chips off this massive assembly line.
The first is exactly what you would expect. Chips designed for terrestrial use, specifically to power Tesla vehicles and their Optimus humanoid robots.
But the second type is a highly specialized space-grade chip. These are destined for solar-powered AI satellites that will be launched into orbit via the Starship rocket platform.
Which is wild to think about.
It really is. I have to ask, why go through the immense friction and cost of launching data centers into space?
Because it actually solves the 2 most critical bottlenecks facing the industry right now, which are energy and geography. Musk explicitly noted the reality that absolutely no one wants artificial intelligence computing centers built in their backyard.
Oh, for sure. Ground-based data centers consume staggering amounts of local grid power.
And they require millions of gallons of municipal water just for the cooling systems. By moving the infrastructure into low Earth orbit, you completely eliminate that geographic friction.
Oh, wow. So you tap directly into unmitigated solar energy without the interference of weather or an atmosphere.
Right, and you utilize the ambient freezing temperature of space for free thermal cooling. Musk actually projects that this space-based compute will undercut ground costs within just 2 to 3 years.
That is essentially like building a literal Dyson swarm for server racks. Instead of wrapping a star in solar panels to capture its energy, you're, surrounding the planet with an orbital mesh of processing power.
Constantly fueled by the sun and cooled by the vacuum of space.
Musk is consistently willing to bet against industry norms regarding what is physically and economically possible. He's positioning Terafab as step 1 toward a galactic civilization.
Outlining this grand vision of a post-scarcity economy that eventually provides abundance for everyone.
While one initiative is trying to build a post-scarcity future in the vacuum of space, another is applying that exact same level of advanced computation to modernize a physical industry that really hasn't changed in centuries.
It's a fascinating parallel. Take Halter, for example.
Right. This is a New Zealand startup that is reportedly nearing a $2 billion valuation.
This upcoming funding round is heavily oversubscribed and led by Peter Thiel's Founders Fund. That effectively doubles Halter's valuation from the $1 billion they reached after a massive raise last June.
And their core technology, proprietary solar-powered collars worn by cattle.
They utilize an artificial intelligence system brilliantly named the Cowgorithm.
The Cowgorithm, I love that.
And the mechanics of how this transforms farming are incredible. The hardware creates virtual fences. It allows ranchers to herd thousands of cattle remotely through a mobile application.
But instead of relying on physical wooden barriers or, using farm dogs and all-terrain vehicles to manually move the herd, the collars guide the animals using specific vibration and audio cues.
Which is such a massive leap forward.
I need to pause on the mechanics there, though. How exactly does a vibration on a collar replace the physical presence of a sheepdog or an electric fence? Are they just buzzing the cow until it gets annoyed and walks the other way?
No, it relies entirely on fundamental behavioral conditioning. The collar emits a gentle audio tone when the animal approaches the boundary of a virtual pasture that the farmer has drawn on their smartphone screen.
Okay, so it starts with sound.
Right. If the cow continues walking forward, the audio changes pitch, which is then followed by a gentle vibration. The animals quickly learn to associate the initial audio cue with the physical boundary, and they simply turn around before the vibration even occurs.
That makes sense.
It is highly precise, completely stress-free conditioning. And the sheer volume of information being processed to orchestrate an entire herd this way is immense.
Yeah, I can imagine.
Each individual collar sends over 6,000 data points per minute back to the proprietary AI.
6,000 data points a minute per cow. That is an absolute flood of telemetry. They're tracking the animal's minute-by-minute health, its exact movement, and constantly optimizing the grazing patterns to preserve the soil.
They started out testing this on a 300-cow dairy farm in New Zealand.
And they have now collected over 7 billion hours of animal behavior data, leveraging that massive data set to expand their operations directly into the U.S. market.
This proves a crucial point about where the real economic value of this technology lies. The most lucrative applications of artificial intelligence might not be found in creating yet another conversational chatbot on your laptop.
Right. The real value is found in digitizing old-school, physical, and often messy industries.
When you replace physical fences, manual herd checks, and reactive veterinary care with continuous real-time data streams, you bring precise algorithmic optimization to agriculture.
It demonstrates that massive value is unlocked when you interface directly with the physical world, managing resources with a level of granularity that was previously impossible.
Exactly. And that shift from massive hardware bets to real-world integration is exactly what we're seeing play out across the broader corporate landscape right now.
While the hardware infrastructure gets pushed to the absolute physical extremes, the software and policy sides are making incredibly aggressive maneuvers behind the scenes.
There is a very deliberate, measured shift happening in how these corporations are structuring themselves. The corporate expansion strategies currently unfolding present a very stark contrast to the broader economic trends we are seeing.
Take OpenAI, for instance.
Yes. While the wider technology industry has experienced a distinct wave of layoffs, many of which are driven by automated efficiencies, OpenAI is moving in the exact opposite direction.
They're in the middle of a massive, aggressive hiring push. They plan to nearly double their workforce, growing from 4,500 employees to over 8,000 by the end of 2026.
And what is really telling about this hiring surge is the specific focus of their recruitment. They are aggressively hunting for what they call technical ambassadors.
Technical ambassadors.
Yes. These are highly specialized personnel tasked explicitly with helping enterprise clients maximize the utility of the models.
It is a clear pivot in strategy. They are no longer just focused on purely developing the underlying technology in a research lab. They're building an army of specialists to ensure massive businesses can actually integrate this technology into their legacy workflows without getting lost.
Meanwhile, the race to establish that orbital infrastructure we discussed earlier is accelerating much faster than anyone anticipated.
Jeff Bezos' space company, Blue Origin, has officially entered the orbital data center race.
They recently filed the necessary paperwork for Project Sunrise. This proposed mega constellation is staggering in scope. It would consist of 51,600 solar-powered data center satellites.
Wow, 51,000.
All explicitly designed to perform advanced computation directly in low Earth orbit.
Filing for a 51,000 satellite constellation puts Blue Origin on a direct collision course with the Terafab project we just unpacked, not to mention SpaceX, StarCloud, and Google's Project Suncatcher.
The battle for computational supremacy is no longer constrained by terrestrial borders. Multiple major players are now committing vast, multi-billion-dollar resources to secure orbital real estate before it fills up.
Down on the ground, the model and platform updates are entirely focused on workflow integration and automation. Anthropic just introduced some significant new capabilities to the Claude ecosystem.
They rolled out a new Co-work Projects feature, which allows you to seamlessly import your existing web-based projects directly into their desktop application.
Additionally, the Claude Code platform now fully supports recurring tasks. This means you can entirely automate routine, scheduled development workflows without needing to manually trigger them every single day.
Anthropic also released a research preview of a feature called Claude Code Channels.
This is particularly interesting because it allows you to send messages and commands to active Claude Code sessions through external platforms like Telegram and Discord.
This specific functionality closely mirrors the capabilities we previously saw pioneered by OpenClaw. It completely bridges the gap between your heavy professional coding environments and the everyday communication apps you already have open on your phone.
In a completely separate platform update, the development team behind Cursor recently confirmed a major technical detail.
They revealed that their Composer 2 coding model was actually built on top of the Kimi K2.5 architecture.
This confirmation only came out following considerable community backlash when that underlying framework was conspicuously omitted from their initial launch announcements.
On the regulatory front, the policy landscape is rapidly tightening. The White House has just released a new artificial intelligence policy blueprint directed specifically at Congress.
The core design of this framework is to maintain federal oversight by utilizing existing governmental agencies rather than creating entirely new regulatory bodies.
The irony here is palpable. While companies like Musk's and Bezos's are literally trying to move data centers into the vacuum of space to avoid geographic friction, the administration is trying to pull regulatory power firmly back to the center.
To achieve a unified national framework, this blueprint explicitly seeks to block individual states from drafting and implementing their own independent regulations,
Preventing a scenario where the country fractures into 50 different compliance zones.
In legal developments, the mechanics of digital fraud are evolving right alongside these sophisticated tools. A U.S. man has officially pleaded guilty to charges of massive music fraud.
What he did was generate highly convincing synthetic audio tracks, and then he artificially inflated their play counts on major streaming platforms.
By deploying sophisticated networks of automated bot accounts to constantly stream his own generated tracks, he effectively manipulated the royalty payout algorithms.
This operation generated $1.2 million per year in fraudulent revenue, and he is now facing a sentence of 5 years in prison.
Okay, so we have covered galactic civilizations, orbital data center constellations, and sweeping federal policy frameworks. Now, let's bring the focus entirely back down to your immediate reality.
Let's examine the actual trending tools you can deploy at your desk today to accelerate your own specific workflows and cut out the tedious busy work.
If you are looking to streamline team communication without ever leaving your workspace, the first tool on the list is Adapt.
This is a Slack-native artificial intelligence designed purely for team collaboration. It operates entirely within your existing communication channels, so you can retrieve project information, summarize threads, and coordinate tasks without constantly switching between 5 different browser tabs.
They are currently offering up to $500 in free credits for new users to test the integration. If you are an engineer looking to unify your environments, the updated Claude ecosystem is incredibly powerful right now.
By combining the new co-work projects, the Claude code channels, and the dispatch integration, you can unify your heavy coding environment directly with your project management systems.
It centralizes your task execution and your version control into a single cohesive interface.
For pure software development, you should look at Composer 2 from Cursor. This is their dedicated coding model positioned as a highly powerful and incredibly cost-effective solution for rapid code generation.
If you're trying to quickly prototype new software or tackle complex architecture planning, this significantly reduces the friction of writing endless boilerplate code.
We are also closely tracking an experimental agent memory system called ASMR, developed by Supermemory.
If you are tired of constantly having to remind your artificial intelligence assistant about your specific formatting preferences or the deep context of past projects, this is your solution.
The primary use case here is enhancing recall for highly personalized workflows. It allows an AI agent to maintain continuous context over long periods of time.
Remembering your past decisions so the assistance is always perfectly tailored to how you specifically work. For those working in content creation or marketing, Glam is heavily trending.
It is a specialized photo application entirely driven by the rapid cycle of social media trends. The workflow takes seconds.
You just select a current visual trend, upload a simple base photograph, and the system instantly generates polished, viral-ready content that is formatted perfectly for specific social platforms.
In that same creative space, if you are a designer or a front-end developer staring at a blank screen, Stitch 2.0 is gaining massive traction as a vibe-based design tool.
Instead of manually pushing pixels for hours, you just provide a text description of the aesthetic or the specific vibe you are targeting.
The tool instantly generates beautiful, production-ready user interfaces in seconds. It completely bridges the gap between abstract creative direction and usable front-end code.
If your daily workflow involves data presentation, Embedful offers a massive shortcut. It takes complex, raw datasets and immediately converts them into client-ready charts, tables, counters, and interactive dashboards.
If you spend hours every single week manually formatting data for weekly reporting, this tool eliminates that friction entirely.
Finally, for competitive analysis, we have Context.dev. This tool specializes in instant data extraction.
You just provide it with any URL, and it completely scrapes the target, instantly converting it into clean Markdown or HTML.
It then utilizes advanced extraction to pull specific brand data, pricing, or feature lists, making it an invaluable tool for researchers who need to aggregate market information quickly and cleanly.
The landscape of computation is fracturing in truly fascinating ways. We're seeing a simultaneous push outward into the zero-gravity environment of low Earth orbit and a push downward, integrating deeply into the soil and the biology of agricultural pastures.
The infrastructure powering our future is becoming entirely detached from the screens and servers we interact with every single day.
You won't see the data centers of tomorrow. They will be silently orbiting above the atmosphere, powered directly by the sun.
Or quietly processing billions of telemetry points on the neck of a grazing animal in New Zealand. The massive centralized server farm in the desert is no longer the only path forward.
It leaves us with a compelling question to consider. As compute becomes ubiquitous, entirely invisible, and completely detached from traditional physical constraints, where exactly will the next massive data unlock happen?
It's a lot to think about. Make sure to follow the show on your favorite platform to stay updated on these rapid industry shifts.
And share this deep dive with a friend or colleague who needs a concise, factual catch-up on the current state of the technology.
See you in the next episode.